This is Senior Algebra, Section 2.8, Solving Inequalities. So today we're taking a look at graphing intervals in a number line, what's known as interval notation, proper interval notation, using properties inequalities, solving inequalities. Let's review, just remember here what the inequalities were: less than, greater than, less than or equal to, greater than or equal to. So we start with example 1. It says write the inequality in interval notation and graph the interval. So the first one, we have x is greater than 5 here. So let's graph it first here, at least this first one, and then we'll talk about what interval notation is. So x is greater than 5. Remember, I have the open circle, the closed circle. The open circle means I do not include that number. The closed circle, the filled in circle, means I do include it. In this case, I don't want 5. I only want the ones that are greater than 5, so it's an open circle here. We want the ones greater, so I'm going to shade to the right. So interval notation is this. It's a way to represent the answer. When you use a parenthesis, that would mean not including that number. When you use a bracket, it means it's included. So if I want to describe the numbers from 5 all the way to infinity, I'm going to start at 5. I can't include 5, so I'm going to use a parenthesis there. And I want to include all the numbers greater than 5 here. So that's 5, 6, 7, 8, 9, 10, 11, 12, all the way to infinity. So the interval is from 5 to infinity here. I use parentheses around the 5 because I can't have 5 and I can never get to infinity. So I'm going to use a parenthesis there. In the second one here, we have negative 3 greater than or equal to y, or y is less than or equal to negative 3. I want the ones that are less than negative 3, so I'm going to start at negative infinity, the smallest number, and go all the way to negative 3. In this case, I'm going to use a bracket because I can include negative 3. So negative 3 is my right-hand point. It's a filled-in circle, and I'm going to the left because I want the ones that are less than negative 3. In C, it's a compound one, meaning there are 2 of them. I'm going to start at negative 2. I'm going to go all the way to 8. Negative 2, I'm going to use a bracket. That's a filled-in circle there. And 8, I'm going to use a parenthesis. Again, bracket when I include it, parenthesis when I do not. So that's all the numbers, negative 2 to 8, that we're looking at. Another way to see it is to use, instead of the open circle, closed circle, to just use a bracket and a parenthesis there, and then fill it in. So if I looked at...
Following students again have messages to pick up in the office at this time: Cole Rip, Joel Norris, Colin Murphy, Kenny McCarthy, Sarah Pufall, Lucas Bomeister, Heather Bartles, Kennedy Busson, Katie Engwall, Courtney Meinholz, and Hallie Murray. Thank you.
Thanks for that wonderful announcement, Mr. Kirsten. So in this one, we're looking at negatives with inequality. So if I start with this idea, 3 is less than 7. Is that true? Yes. Well, if I add 3 to each side, I get 6 is less than 10. Is that true? Yep, that's true. Subtract 2 from each side, 4 is less than 8. Still true. If I multiply both sides by 3, I get 12 is less than 24. That is still true. When I multiply each side by negative 2, I get negative 24 is less than negative 48. That's actually false. So what happened here? Well, I mean, when I multiplied by a negative, it didn't work out, right? We went from a true statement to a false statement. So what could we do to make it a true statement? Well, negative 24 is less than negative 40. That's false, but what if I flipped it? What if I wrote it, flipped the inequality, and I wrote it negative 24 is greater than negative 48? And that's actually what we do. The rule is this: when I introduce, meaning I put it into the problem, and I multiply or divide, I must switch the inequality. So in example 2 in part A, It's 3 times x, so I divide by 3. In this case, I introduced a 3. I divided by 3 in the problem. So I get x is greater than negative 6. In this case, I do not have to switch it because I divided by a 3, a positive 3 here. The interval notation, x is greater than negative 6, so I'm going to start at negative 6, go all the way to infinity. I use parentheses because I don't include those numbers. The graph, open circle at negative 6 to the right. Could have also used a parenthesis there. In B, I'm going to divide by a negative 4. So I get x and I get negative 3 here. But I introduced, meaning I put a negative 4 into the problem. So that means I have to switch the inequality. X is less than negative 3, so close circle at negative 3, shade to the left, and the interval notation would be negative infinity to negative 3. Those would be all the numbers that I include there. In example 3, A and B, now we get into a little bit more difficult problems. Same idea though. I'm going to combine everything on the left side, combine everything on the right side that I can. And now I have an option here. Do I want to move the x's to the left side or the right side? And this is where kind of looking ahead will help. In this case, I'm going to try to keep the x's positive. So I'm going to get rid of the negative 2x by adding 2x. Could you do it the other way? Sure, not a problem. You would just end up with a negative, you'd have to flip it, and that's fine. You would still end up with the same thing. So I get negative 12 is greater than or equal to 6x. So x is going to be less than or equal to negative 2. In this case, notice I did not flip it, even though I was dividing with a negative because I didn't introduce it into the problem.
Grace Wellness, please report to the counseling office at this time. Grace Wellness, please report to the counseling office at this time.
One more announcement. Interval notation will be negative infinity to negative 2. That's a closed circle at negative 2, shade to the left. Notice I used a bracket at negative 2 because I'm including that. In the last one, this is similar to one of the problems we looked at when we graphed it. It's a compound inequality, meaning there's pretty much 3 parts. Usually there's a left side and a right side. Well, now I have 3 different parts here, the left side, the middle, and the right here. So I'm going to work to get x alone in the middle. Well, how do I do that? If I get rid of the 5, if I add 5, I'm going to add it to all 3 parts there. So I'm going to get 9 less than or equal to 3x less than or equal to 11. How do I get rid of the 3? It's 3 times x, so I'm going to divide by 3. Divide each side by 3, and by 3. I get 3 less than or equal to
Joel Norris, Colin Murphy, Sarah Pufall, Lucas Bomeister, Kennedy Busson, Courtney Meinholz, and Hallie Murray have messages to pick up in the office. Thank you. Also, Emily Pataki.
A lot of announcements this morning. So I have 3 is less than or equal to x, less than or equal to 11 thirds. 11 thirds, that's 3 2/3 here. So I'm going from 3, close a bracket, because I can use that, all the way to 11 thirds. A parenthesis means I don't get to 11 thirds. The graph here, I apologize, it kind of sucks. I should have made it a little bit larger. So I'm at 3. I'm going to go to 11 thirds. That's 3 2/3, so it's a little bit there. It's a closed circle at 3, open circle at 11 thirds. Bracket to a parenthesis there.